Okay, Gopinath. Okay. Now, before going to the today class, just we'll revise Green's theorem. What is the statement of the Green's theorem? If C is the closed curve and R is the region included by the closed curve C, then the line integral P dx plus Q dy is equal to double integral of dou Q by dou x minus dou P by dou y into dx into dy. So here P and Q both are continuous functions. I think in the previous class we have seen two problems. This is the first problem, and this problem we did in the two ways, by using the line integral as well as by using the Green's theorem. Green's theorem, yes, by using Green's theorem. And second problem, so this one also we did by using the line integral as well as by using the Green's theorem. Yes, Green's theorem. And I think I have given four more problems. This for first two problems, 1 2, so 3 4. I think these four problems I have given. Now, so we will solve same problem in the different manner. That means by using the double integral. That means we will use the Stokes theorem. Okay. So before going to the problems now, so I think all of you know what is the statement of the Stokes theorem. Stokes theorem. Statement of the Stokes theorem.
Surface integral of curl of vector over a surface is
Huh?
equal to line integral of vector over a surface bounded by closed curve.
Very good. So here line integral. So line integral on the closed curve C, f dot dr is equal to surface integral of n. That means n means here the unit normal vector curl f dot n cap ds. So here where n indicates the unit normal vector, normal vector of any point of S. So here S indicates the surface. Okay, assume it is the y-axis, it is the x-axis, and S is the surface bounded by curve C. Okay, assume it is the curve C. So this is the S. This is the S. Okay, so this is the statement of the Stokes theorem. ఇది చెప్పారు సిఆర్ మీరు. సో Stokes theorem.
చెప్పాలా సార్?
No need. Now here the line integral of any vector function around the line integral of the any vector function around the closed curve C is equal to surface integral of the curl f take over any surface which is curve is boundary edge. That is the statement of the Stokes theorem. Now I will write the statement of the Stokes theorem. Stokes theorem. If the line integral. So line integral of a vector function or vector point function f around any closed curve C is equal to the surface integral of, that means double integral, surface integral of curl f take over any surface of which the curve is a boundary edge. That means this surface is bounded by C. So boundary edge. Okay, or mathematically we will write here the line integral of f dot dr is equal to the surface integral of curl f dot n ds. And here the ds may be the related to the xy plane or xz plane or yz plane. Okay. Now, so we will see the previous problems. A problems. Okay. Yes. Yes. Now we will see this. Today we will discuss only two problems. Just two problems. After that, I will give the homework. So A problem solutions here. This first problem. So the evaluate the line integral xy dx plus xy square dy. C is the curve. So square in the xy plane. Sorry. Govind Rajendra. Hello. Okay, so already we know the answer 4 by 3. Now we will solve this problem three ways: by using the line integral, by using the Green's theorem, by using the Stokes theorem. Already we know the result. The result is 4 by 3. Okay. So this is our first question, and the second question according to the time we will solve. Okay. Now the first question here. Evaluate the line integral. Evaluate line integral xy dx plus xy square dy, where C is the curve square in the xy plane, and lines are x is equal plus or minus 1 and y is equal plus or minus 1. That means it is the A square region. Now, so we will solve the three varieties. First one, second one, and third one. So first one is by using the just normal line integral. We'll apply the line integral. So line integral approach. So now the first one is the, so according to the line integral. So before that, first of all, draw the diagram. So what is the structure? Okay, assume it is the y-axis, it is the x-axis, and it is given that plus x is equal plus or minus 1 and y is equal plus or minus 1. That means, okay, assume it is the plus 1 and this is the minus 1, this is the plus 1 and minus 1. So here we have the, this is the x is equal to plus 1 line, and this one is x is equal to minus 1 line, and this is the y is equal to plus 1 and y is equal to minus 1. So this is our region. Now this region and this is the region, and this region is bounded by 4 lines. X is equal to 1 line, and y is equal to 1 line, and x is equal to minus 1 line, and x is equal to plus 1. So we will split into now the 4 regions. So it is the assume A, B, C, D, and assume this one is the C1 curve, and assume it is the C2 curve, and C3 curve, and C4 curve. So according to the previous one, so this single integral, so integral of C d f dr is equal to, I am splitting into 3 integrals, f dot dr, first integration, second one is C f dot dr, next one, third one, C3 f dot dr plus C4 f dot dr. Okay, now we will solve one by one. First of all, along the C1 curve. So along the C1 curve, that means along the AB curve. So along AB curve, C1 curve. That means along AB. Along AB, what is the structure? So y-axis, x-axis, and this is the x is equal to 1 line, and this one is x is equal to minus 1 line. This one is the y is equal to 1 line, and this is the y is equal to minus 1 line. Now we are here. So it is the AB and C1. Now along this one, now what is the x value? So x is fixed, x is equal to 1, and y is running from minus 1 to plus 1. Now what is our line integral? So line integral is x y d x plus x y x y square dy. C1. In this one, what are the limits of the x limits and y limits? So here the x is fixed, so that is dx is equal to 0, and y limits are running from minus 1 to plus 1. Now substitute. After substituting, what will get here? Integral minus 1 to plus 1 y limits, and x is equal to 1. So 1 into y, it is 0, plus x is equal to 1 into y square dy. That means minus 1 to plus 1. Now 0 y square into dy. Anyway, this is the even function. We can have 2 into integral 0 to 1 y square into dy. That means 2 into integration of y square is y cube by 3, limits from 0 to 1. So our result is 2 by 3 is the first result. Similarly, come to the second one. Just I am copying this one. So this is the first path. Similarly, now the second path. So second path here I am taking in the next direction, BC direction. So BC direction. So BC direction. So in this direction, BC. So it is C2 direction. So BC. So in the BC direction, what is the x value? What is the y value? BC direction. So here C2 curve. That means BC direction. So here the x values are running from 1 to, so here y is equal to 1, but x is running from 1 to minus 1. 1 to minus 1. ఒక్క నిమిషం అండి. So 1 to minus 1. In this one, dy is equal to 0, and x is running from 1 to minus 1. Now the line integral on the curve C2. So limits from minus 1 to plus 1 to limits integral x is equal to 1 to minus 1 and y is equal to 1 into dx plus here the dy 0. So entirely it is the 0. So integration of this one is, so integral x is equal to limits from minus 1 to plus 1 x into dx. After rewriting means after interchanging the limits, integral a to b f of x into dx, you can write minus integral b to a f of x into dx. So after changing the order of the integration here, after interchanging the limits, this result is minus integral minus 1 to plus 1 x into dx. Anyway, this x is the odd function, so the result is entirely 0. So integration of odd function from minus a to plus a, this result is 0 if f is an odd function. 0 if it is, suppose f is an even function, it is the 2 times of integral 0 to a f of x into dx. So on the second curve the result is 0. Now come to the third one. So third, that means, so second one is the BC direction. Next one CD direction. CD direction. In the CD direction, x is equal to minus 1. So that means C3. So C3, that means CD direction. In the CD direction, x is equal to minus 1 and y is running from 1 to minus 1. So 1 to minus 1. Now C3. So in this one, so our limits are 1 to minus 1 and x is equal to minus 1. So here x is minus 1 only, not plus 1. So x is equal to minus 1. So here minus 1 and this is as it is. So here we'll get the limits are here the 1 to minus 1. After changing the order of the integration, x is equal to minus 1, here we will get the minus 1 only. So here minus 1, after interchanging the order of the integration, we will get the integral minus 1 to plus 1 y square into dy. Now anyway y square is the even function, we can write 2 into integral 0 to 1 y square dy. After solving we will get the 2 by 3 is the result. So it is in third direction. C3 direction. Next one C4 direction. So C4 direction. So in the C4 direction, so it is the C3 direction, the previous one, C2D, and the C4 direction is DA direction. So C4 DA direction. So DA in this one, so y is equal to minus 1 and x is running from minus 1 to plus 1. So minus 1 to plus 1, just limits minus 1 to plus 1. X is minus 1 to plus 1 and y is equal here minus 1 and the dy is 0, so entirely 0. So after rewriting, okay, malli rastunnanu. So after rewriting, integral minus integral x is equal to minus 1 to plus 1 x into dx. Anyway this x is the odd function, So integration on -1 to +1 is entirely 0. That means here what are the results we have? C1, C2 results. So C1 result is, I am assuming it is the equation 1, equation 1, 2 by 3, C1 along the C1, and along the C2 we have the 0, along the C3 we have 2 by 3, along C4 we have the result 0. Now come to the first one. What is our assumption? Okay, assume this is the equation star. Now from the equation star 1 2 3 4, now this result is, so 2 by 3 plus 0 plus 2 by 3 plus 0, the result is, get the 4 by 3. So 4 by 3, so this is by using the line integral. Now same problem we will solve by using the Green's theorem. So evaluate by using the Green's theorem. Green's theorem. So what is the statement of the Green's theorem? Green's theorem. Green's theorem. Sears. Green's theorem.
So integral region over
Integral
dx minus
pdx plus q dy is equal
0.
double integral
So region
dou q by dou
by
x
dou x minus dou p by dou y.
dou p by dou y. Very good. Into
dx dy.
dx into dy. Okay.
Mm.
Now come to the our problem. Our problem is line integral xy dx plus xy square dy on the closed curve. What is the curve here? It is the region, square region. So square region. So limits are, x limits are plus or minus 1, y limits are plus or minus 1. 1, 1, minus 1. So this is our region. This is the region. This is the region. This is our region. This is our region, and here this is the x is equal to 1 line, x is equal to 1 line, and x is equal to minus 1 line, and y is equal to 1 line, and y is equal to minus 1 line. So this is the region. Now compare. So now what is our statement? Line integral of c p dx plus q dy. Now compare what is our p, what is our q. Just we have to compute. P is equal to xy and q is equal to xy square. Now what is the statement by using the Green's theorem? It is the double integral of dou q by dou x minus dou p by dou y into dx into dy. Now dou p by dou y, after differentiating we will get the x, and dou q by dou x will get the, what is the expected result? It is the y square only. So y square. Now after substituting, so double integral of dou q by dou x y square and dou p by dou x dx into dy. Now come to the limits. The limits are already clearly given. It is the rectangular region. That means x is equal to plus or minus 1 and y is equal to plus or minus 1. Now the limits are, you can take any one of the order, but now I am taking the order is y is equal to minus 1 to plus 1 and x is equal to minus 1 to plus 1, and we cannot split into now two single integrals because we cannot evaluate. Okay, So here now it first of all evaluate the first of all x limits. Integration of x is equal to -1 to +1 y square minus x into dx into dy. సో డైరెక్ట్ సాల్వ్ చేస్తున్నానండి. నో మళ్ళీ ఒకసారి వస్తాను. సో ఇంటిగ్రల్ y ఈజ్ ఈక్వల్ టు -1 to +1 అండ్ x ఈజ్ ఈక్వల్ టు -1 to +1 y square minus x into dx into dy. Now this is the now limits from -1 to +1. This is the odd function, so it is entirely 0. Okay, వద్దులే డైరెక్ట్ సాల్వ్ చేద్దాము. ఓకే, విల్ డైరెక్ట్. సో y square after integration we'll get the x square by 2 limits from -1 to +1. Upper limit is 1, so y square -1 by 2 and lower limit is -1, so minus y square -1 by 2. So -1 by 2 -1 by 2 cancel, we get the 2y square. So 2y square is the first integration result. Now the second integration, y is equal -1 to +1 and y is equal -1 to +1, and here y is equal -1 to +1 2y square into dy. After simplification, now first of all it is the even function, we can split into like this, integral 0 to 1 2y square dy. After integration 4 into y cube by 3 limits from 0 to 1, we'll get the 4 by 3 is the answer. Okay, so this is by using the Green's theorem. Now come to the same problem, we'll solve by using the Stokes theorem also. Now so just apply on these problems, just apply the Stokes theorem. Stokes theorem, that is our third one. So anyway we know the result. What is the result? The result is here 4 by 3. So now we'll apply the Stokes theorem. Stokes theorem, Stokes theorem. What is the statement of the Stokes theorem? Cheppana? Stokes theorem. Statement of the Stokes theorem. Line integral of df dr is equal to surface integral of curl f dot n dA or ds. So this is the statement of the Stokes theorem. Now the Stokes theorem. Now what is our question? Our question is line integral of x y dx plus x y square dy. So first of all you have to identify the f. What is our f here? Now the f is the vector. The vector is here x y I plus x y square j plus 0 into k is our vector. So first of all you have to find the curl f. Curl f. What is the curl f here? Curl f is equal or del cross f is equal to I j k dou by dou x, dou by dou y and dou by dou z. Second row, third row is x y square and 0. After finding the determinant of this matrix, 0 minus j into, after differentiating it is 0 and 0 plus k into, after differentiating with respect to x it is the y square, and after differentiating with respect to y you will get the minus x. So the vector is curl f is the k into y square minus x. So this is the next one. Here the ds, here the unit normal vector, already it is clearly given, it is related to the xy plane. In the xy plane, xy plane in the xy plane, our eta is equal, you have to take the k. Now come to the this Stokes theorem. So statement of the Stokes theorem, already we know the Stokes theorem is line integral of f d r is equal surface integral of del cross f dot n into ds. Already it is the xy plane, so xy plane, it is in the surface integral. So line integral, what is the del cross f? So del cross f, already we know that. What is the del cross f here? K into y square minus x square dot, and here the unit normal vector is the k, and it is the xy plane, so dx dy, and the limits already is clearly given. X y is equal minus 1 to plus 1, and x is equal minus 1 to plus 1. So now the result is integral minus 1 to plus 1, x is equal minus 1 to plus 1, k into k is the 1, so y square minus x into dx into dy. Now observe, already we know the double integral of y square minus x dx into dy according to the previous. Already we know the result. This is the result. The result is 4 by 3. Already we know that. Just I am taking this result as it is. I am copying. Okay, so the integration of this one is 4 by 3. Okay. Okay, నిమిషం అండి. So the conclusion is, so the line integral we can solve 3 ways: by using the normal line integral, or by using the Green's theorem, as well as by using the Stokes theorem. Okay, now we will solve one more problem. After that I will stop. Okay, now what is the previous homework problem in Green's theorem? Again a Green's theorem. No. Green's theorem. Okay, so this is the first one. So this is the previous homework problem. So this problem we can solve by using 3 ways: by using the normal line integral approach, or by using the Green's theorem, or by using the Stokes theorem. Next one, a problem solutions here, second problem or third problem or fourth problem.
Second problem, sir.
ఎందుకు సెకండ్ ప్రాబ్లమ్ సాల్వ్ చేయలేదా?
చేసాం సార్.
The 2 methods సాల్వ్ చేశారా?
ఎస్ సార్.
సార్ ఫోర్త్ ప్రాబ్లం కొంచెం సాల్వ్ చేస్తే కూడా బెటర్ అనిపిస్తుంది.
ఫోర్త్ ప్రాబ్లమ్ అండి.
ఫోర్త్ ప్రాబ్లం
ఫోర్ ప్రాబ్లమ్ సాల్వ్ చేద్దాం. ఫోర్త్ ప్రాబ్లం
సార్.
ఓకే. సో ఫోర్త్ ప్రాబ్లం రిజల్ట్, వాట్ ఈస్ ద రిజల్ట్ ఆఫ్ ఫోర్త్ వన్? పై. ఓకే, ఎస్. ఫోర్త్ ప్రాబ్లం సాల్వ్. ఓకే, సో ఫోర్త్ ప్రాబ్లం చెప్తారా? సెకండ్ వన్, ఫోర్త్, నెంబర్ 4. ఓకే, స్టేట్మెంట్ ఏంటండి? f is equal to, what is the vector here? F is equal to 2x minus y. నాగరాజు ఉందా?
మైనస్ yz స్క్వేర్
minus yz square
జే
J
minus y square
y square
zk
zk.
zk
ఓకే, కర్వ్ ఏంటండి? ఓవర్ ద నేను రాసుకుంటాను. సో ఓవర్ అప్పర్ ఆఫ్ ప్లేన్ ఆఫ్ సర్ఫేస్, అప్పర్ ఆఫ్ సర్ఫేస్ of sphere x square plus y square plus z square is equal to 1 bounded by in the projection with projection on xy plane. Okay, anyway, so we will solve 3 ways. 1 2 3. 1 2 3. So first is the first one, just evaluate the line integral. That is the first one. And second question is just to verify the Green's theorem. And third one is the verify the Stokes theorem. That means we have to solve this problem 3 ways. Stokes theorem. Stokes theorem. Numbering better. First problem, second problem, and third problem. Okay, now come to the first one. Now by using the line integral, we will solve. First one, line integral. By line integral, although it is clearly given in xy plane. In the xy plane means, that means projection on the xy plane. What is the z value? Z is 0. And what is the dz? Dz is 0. That means this sphere now becomes after projection, that is became circle. The projection of the sphere on the xy plane, it becomes circle. Okay, సో ఎవరైనా జియోజిబ్రాను పోస్ట్ మాస్ని యూజ్ చేస్తారా అండి? కర్వ్స్ని డ్రా చేయడం మీకేమైనా వచ్చింది అక్క? యూజ్ చేశారు ఎవరైనా? హలో, యూజ్ చేశారా? ఒక్క నిమిషం అండి. curve. ఒక్క నిమిషం అండి. Okay, so we will see later. Okay, so here the line integral in the xy plane, z is equal to 0 and dz is equal to 0. So in the next class I will show you the structure. So this sphere becomes now on the xy plane, it is became a circle. What is the structure of the circle here? Assume it is the y axis, it is the x axis, and x is equal to 1, x is equal to -1, left hand, right, top end is +1, bottom end is -1. So this is the circle, and the equation is x square plus y square is equal to 1. What is our f? Our f is clearly given. F is equal to 2x minus y into I minus y z square into j minus y square into z k. After substituting z is equal to 0, this is this second part must be 0 and third part also 0. Now just do the line integral. Now the line integral f dot dr is equal to 2x minus y into I minus y z square j minus y square z into k dot dxi plus dyj plus dzk. After doing the normal dot product of these two vectors is, we'll get the 2x minus y into dx minus y z square into dy minus y square z into dz. But here already we know that z is equal to 0 and dz is equal to 0. This total integral, now this total integral becomes now integral 2x minus y into dx, the rest of 0 minus 0, and on the curve C. So curve C here we can solve this one is the two ways, because already we know that what is the equation x square plus y square is equal to 1. You can convert into only in terms of x or you can convert into only in terms of y. But if now my suggestion is better to convert into polar form. The polar form is very simple. So x is equal to here what is the cos theta and y is equal to sin theta, and here the dx is equal to here the differentiation of the cos is minus sin into d theta, and theta values are 0 to 2 pi. So just convert into polar form, or you can take like this also. That means
సార్ నాకు చిన్న డౌట్ సార్.
uh,
సార్ మనకి క్వశ్చన్లో అప్పర్ హాఫ్ అని మాత్రమే ఇచ్చినారు కదా, మరి మనం ఫుల్ సర్కిల్ని కన్సిడర్ చేసుకుంటామా, పై హాఫ్ సర్కిల్ని మాత్రమేనా?
అప్పర్ హాఫ్ లో ఏంటంటే హెమిస్పియర్,
అంటే ఓవర్ అప్పర్ హాఫ్ అన్నట్లనే కరువు పార్ట్ ఇచ్చినారు కదా
అప్పర్ హాఫ్
క్వశ్చన్లో.
హెమిస్పియర్. స్పియర్ని పైనుంచి చూస్తే ఏమొస్తుంది? ఇట్ ఇస్ సర్కిల్. ఓకే, స్పియర్ హాఫ్ ఆఫ్ ద స్పియర్ ఈ స్ట్రక్చర్లో ఉంటుంది. ఒక్క నిమిషం.
సార్ అంటే స్పియర్ హాఫ్ పైన సర్కిల్ ఉండొచ్చు కదా
Yes.
ప్రొజెక్షన్
Projection is
సర్కిల్
circle.
పడతా ఫుల్ సర్కిల్ పడతా ఎక్స్ట్రా
హాఫ్ సర్కిల్ ఫుల్ సర్కిల్ ఇక్కడ హెమీ సర్కిల్ కాదు హెమీ ఇట్ ఈస్ హాఫ్ స్పియర్ హెమిస్పియర్ దీని పైనుంచి వ్యూ ఉంటుంది ఇట్ ఇస్ సర్కిల్ ఓన్లీ అర్థమైందా సో బాల్ని కట్ చేసి దాని పైనుంచి చూస్తే ఏమవుతుంది సర్కిల్ ఫామ్లో ఉంటుంది ఎలా ఉంటుంది అర్థమైందా
yes sir
ఓకే సో ఇట్ ఈస్ ద సర్కిల్ సో xy projection it became a circle and here again this line integral we can solve two ways by converting the polar form or by taking the Cartesian form in the Cartesian form అయితే ఎలా తీసుకోవచ్చు just you have to take x limits are -1 to +1 and y is equal to under root of 1 minus x square. That is the first way. Or you can convert it to polar form. So anyway here I am using the polar form. So polar form is integral theta is equal 0 to 2 pi and x is equal, what is the x? X is the cos theta, so and y is sin theta and dx is what is the dx? Minus sin theta d theta. That means now it is divided into two integrals. Now integral 0 to 2 pi sin square theta minus 2 sin theta cos theta into d theta. Now the sin square, so sin square we can write, how can we write sin square? 1 minus 1 by 2 of 1 minus cos of 2 theta minus this one I can write 2 sin theta cos theta, we can write sin of 2 theta into d theta. Now just do the normal integration. Now integration of 1 is theta, integration of cos sin of 2 theta by 2, integration of sin minus cos but already is minus, so plus cos of 2 theta by 2, limits 0 to 2 pi. Apply the upper limit is 2 pi, so 1 by 2 into 2 pi minus sin of 2 pi, it is become 0 plus cos of 2 pi. What is the cos of 2 pi value? 1 by 2 for upper limit. For lower limit, so 1 by 2 of 0 cos also 0 plus again 1 by 2. So here the results are, so pi plus 1 by 2, here minus 1 by 2, the result became pi. Okay, so now this is by using the line integral. Now we will solve same problem by using the Green's theorem also. So Green's theorem, so anyway we know the result, we know that result is pi. So next one, second approach, it is the assume first one. Next one by using the Green's theorem. Mute lo pettandi evaru. Green's theorem, what is the our f line integral of f dot dr ఏమొచ్చిందండి ఇంత ముందు, ఇట్ ఈజ్ ఈక్వల్ టు line integral 2x minus y into dx minus y square z, so yz square dy minus z y square into dz, and here it is clearly given in the xy plane, in the xy plane, in xy plane. So xy plane means z value, z became 0 and dz must be 0. Now this integral now becomes, integral is 2x minus y into dx. Now come to the, what is the statement of the Green's theorem? integral, line integral p dx plus q dy. But here what is the p, what is the q? P is equal to 2x minus y and q is equal to 0. Dou p by dou y is minus 1 and dou q by dou x is 0. So according to the Green's theorem, this line integral we can write double integral of r dou q by dou x minus dou p by dou y into dx into dy. So by using the Green's theorem. Now substitute all the values. Double integral of dou q by dou x 0 and dou p by dou x is, it is what is the result here? It is minus of minus 1 plus 1 into dx dy on the region R. What about here the region? 1 into dx into dy. ఇది మన లాస్ట్ క్లాస్ సాల్వ్ చేసామండి ఇలాంటి ప్రాబ్లమ్స్. వాట్ ఈస్ అవర్ రీజన్? గుర్తుందా? సో హియర్ అవర్ రీజన్ ఈస్ circle. Our region is circle. So circle minus 1 plus 1 minus 1 plus 1 minus 1 plus 1 x square plus y square is equal to 1. So this problem we can solve three varieties. You can use the Cartesian form, or you can use the polar form, or you can use the directly property also. What is the result according to the previous class? This is must be gives the area of the region. Area of the region. I think we did this type of problems in the previous class. Anyway, I will show again. ఇక్కడ సాల్వ్ చేసాం. ఒక్క నిమిషం. Yes, here. Okay, so this is the previous. So after applying the Green's theorem, we will get the here double integral of 1 dx dy. So the result is here the area of the region. Here the circle equation is x square plus y square is equal to a square. Now we will get the result is pi a square. This is the by using the formula, or by using the Cartesian form also we can solve. The result is the pi a square, or by using the polar form also we can solve. Okay, so anyway directly I am using the results, I am not solving because already we know that. Okay, but anyway try to solve in the two ways, by using the Cartesian form as well as by using the polar form. Try చేస్తారు కదండి. So pi into 1 square, what is the here the radius is 1, so we'll get the pi is the result. Okay, clear? So this is our second result by using the Green's theorem. Next one come to the by using the Stokes theorem. Stokes theorem, third one. I will apply the Stokes theorem. Stokes theorem. What is the statement of the Stokes theorem? Line integral is equal to surface integral curl del cross f dot n unit orbital vector into ds. Now in this one, what is the our f? F is, what is the f? Clearly given. What is f? 2x minus y into I minus yz square j minus zy square k. So first of all do the curl f. Curl f is equal to, or del cross f, that is equal to, first row is ijk, second row is dou by dou x, dou by dou y, dou by dou z, and the third row is 2x minus y minus yz square minus zy square. Now I into, after differentiating with respect to y, here we will get the minus 2yz. After differentiating with respect to z, we'll get the minus, but minus or minus plus 2yz minus j into, after differentiating with respect to x it is 0, after differentiating with respect to y it is also 0, minus plus k into, after differentiating with respect to x it is 0, after differentiating with respect to y, here we'll get the minus of minus 1, so plus 1. So here we'll get the result is I into 0 minus j into 0 plus k only. So here we'll get the k, and it is clearly given in the xy plane. Already it is clearly given in xy plane. xy plane. So xy plane means what about our unit normal vector? Our unit normal vector is the k, and x square plus y square plus z square is equal to 1. That means you have to assume xy projection. So z must be 0. Now already here the unit normal vector is k and curl f is k. Substitute all. So Stokes theorem. So line integral f dot dr is equal surface integral of del cross f dot n into ds. That means here we'll get the surface integral. It is what is the, it is the k and n also k, dx into dy, and xy plane. So xy plane means x square plus y square is equal to 1 only. It is the region. So now 1 into dx into dy. What is our here s? S is x square plus y square is equal to 1. What is the result of this one? గుర్తుందా అండి? Area. So area is pi into 1 square is the result. So pi is the result. Okay? Clear? So this is our third result. Okay na andi?
Okay, sir.
So now we'll conclude. So from the equation 1 and equation 2, so Green's theorem is verified, and from the equation 1 and equation 3, Stokes theorem is verified. Stokes theorem verified. Okay. So finally the question, sometimes they will give the question like this: just evaluate the line integral. So evaluate the line integral means we can take the any one of the option. That means you can apply the normal line integral approach, or you can apply the Green's theorem, or you can take the Stokes theorem. But sometimes the question is maybe like this: verify the Green's theorem. So verify the Green's theorem means you have to solve that problem two ways. That means by using the line integral or by using the double integral. Similarly, same, verify the Stokes theorem. That means in that case you have to solve two ways. You have to apply the line integral as well as you have to apply the surface integral. Okay? Am I clear? మీకు హోంవర్క్ ఏంటండి? హోంవర్క్. What is the homework? Already two problems ఉన్నాయి కదా మనకి. Yes. So I think first problem is over and fourth problem is over. That means now we have the remaining two problems. This second problem and third problem just do in three varieties. That means apply the line integral, apply the Green's theorem, and apply the Stokes theorem. And one more also, already in the previous class we have seen this first problem. So first problem I think I have done in two ways. Now same problem, just apply the Stokes theorem also. Just copy చేస్తున్నాను, just do this problem, copy. So this is our first homework problem, just to try to solve. It is the first problem. Vector integration. Second problem, this is the second problem. Second problem, and already we did in 2 ways, but add one more. Add the one more. It is the second problem. And third problem, okay, this is the third problem. Answer is a cube by 2. A cube by 2. A cube by 2. Okay, one more also. Okay, so try to solve these 3 problems. Okay, ఇంకా వీలైతే జస్ట్ గ్రీన్స్ థియరమ్ ఉన్న ప్రాబ్లమ్స్ అన్ని సాల్వ్ చేయండి. ఓకే, క్లియర్? ఇంక ఇవాళ సిఆర్ హోంవర్క్ ప్రాబ్లమ్స్ సరిపోతాయి.